Hello and welcome back to a new tutorial where today I'm going to show you how to write a binary search system in Python. Binary search systems are a bit more advanced than linear searches, which is what we did last time. If you haven't seen that, there is a card right there at the top of how to write a linear search system. So this is kind of the natural progression. As you can see by the thumbnail, this involves using the midpoints, the max points and the low points. Even though it's a bit harder, it is still fairly simple to get your head around. So let's first do it in PowerPoint, because if you can visualize it, you can code it. So we'll have to have our array, and unlike linear search, our array has to already be sorted. It needs to be numerically increasing. This is increasing in alphabetical order because letters are just numbers, which is a strange thing to say, but kind of makes sense, because A responds to 1, B responds to 2, kind of like that. So let's say we were looking for E. The first thing we're going to do is we're going to find our maximum and our minimum. And then from our 2 points, we're going to work out where the midpoint is. Next thing we're going to do is we're going to check, is our midpoint the letter we're looking for? In this case, it's not. We're looking for E. So the next thing we're going to do is we're going to move our card over to midpoint and try -1. As you can see, that doesn't work with the endpoint because we would have moved in the wrong direction. So if that doesn't work, we'll use our small points. We'll move our small points, we'll go back a place, and we're going to check. So now our midpoint is in the center. So that means we can check. If it still wasn't, we would keep moving our points until our midpoint is the letter we're looking for. That might not still be clear, so let's try doing it in some code. But basically, you're trying to halve the amount of data you sort through each time. So here is our Python script. I've already made us an array. It's already in the right order, just to make life a bit easy. Oh, there is a sneaky space in there. So first, let's create ourselves a function. Do the normal way where I'll write the code and then I'll try and explain a little bit as I'm going through it, but I'll do a final summary. So we'll create our new function and we're going to call this binary search, just because that makes sense. We need to give it 2 pieces of data. We need to give it our array that we're sorting through and our key. Our key is what we're looking for. We create a new variable and we're going to call that start. We're going to create a second new variable and we'll call that end. And end is going to be equal to length of our array -1. And this is because arrays start counting at 0. So even though there's 6 items here, that's only our 5th item. That is our 0 item. Now we're going to create a while loop. So while start is less than equal to end, we'll keep searching. And this is basically, so if we get to the end of our array, we know it doesn't exist, so we give up. So first we're going to do our first check, which is if array is equal to mid. We didn't define mid. So we should probably define mid at the top. Mid is equal to start plus end. And then we're going to use floor division, divide by 2. But you can do floor division with 2 backslashes. The reason we're using floor division is because we don't want decimal points. You can't have a point of an item. It doesn't work. 0.3 of a book, you generally want the full book. 0.2 of your phone, you kind of want your whole phone. It doesn't quite work, so we use floor division. And you find any sorting systems that use division will use floor division. Anyway, so if our midpoint is already equal to our key, but then we can just return midpoint. And this is our ideal solution, that it happens first try. Rarely does, but we put the check in place. Next thing we're going to do, if our array dash midpoint is bigger than what we're looking for, so greater than key, but then we're going to want to remove the second half of our array. Split our data in half. The way we do this is end is equal to mid minus 1, and then else we want to do, there we go, start is equal to mid plus 1. And the reason we are just using an elf here is because if it doesn't fit these two criteria, this is the only possible solution. And then we'll go back to our while loop and we'll return minus 1. The returning minus 1 means that it couldn't find the data. Minus 1's our error code here, so we'll just return minus 1. So let's test this quickly. We'll print binary search. We will give it the name of our array, which is names, and let's look for car. We'll save this and we will run it, and it is at position 2, so 0, 1, 2. So you can see it's there. Let's look for egg. You can see it is position 4 and it's 0, 1, 2, 3, 4. So that works fine. So this is a really common thing used in computer science. There is a link to that playlist of other computer science videos. Thank you for watching. Please leave a comment if you want anything explained, or suggestions for other searching systems, sorting systems, or other kind of computer sciencey videos you may want to see. Thank you for watching. See you.